So this is MATLAB that you're looking at here. I guess the starting point is, let's bring this down so you can shrink it down a bit to a more manageable size. So this is a sample MATLAB window. My cursor now is in the directory of your computer, so we all know your computers have directories. And hopefully you're organized and know, and you put various things in various different directories. MATLAB works very closely with your directories, but that will come up later. But for now, sort of note that this is where your MATLAB directory is by default. The window that I'm in, my cursor's in now, this is the command window, and you can think of MATLAB as being a big fancy calculator. You can compute things like 2 plus 2. You can create a vector by doing u is equal to brace 2, 3, 5, brace, and you can hit enter, and that MATLAB will understand u as a vector. If you happen to, you can use the up arrow. I'm using the up arrow to cycle through previous commands. So I'm using the up arrow, and by using the up arrow, I can cycle through all the things that I've been typing, and so on. So that will help you. So if I put a semicolon at the end of this vector declaration, it suppresses the output, so you don't see it anymore. I can create another w, which is w is equal to, say, 1, 2, 3, and I can, so now u is a vector, now w is a vector. Notice if you put a tick mark on the end of MATLAB, like a little tick, that makes u be actually an honest to goodness vector, whereas, so a column vector we'll say in class, and w is the same thing. If you put a tick mark on the end of it, then w is now a column vector. Then the u dot times should work. Okay, so what does that do? So that produces... Okay, so yeah, so the sum, yeah, so we're doing, that's right, so the sum of that, so that's 23, the other way would be dot u, and I guess this is the easiest way, dot u, comma v. Okay, sorry about that. So notice this way, this is the way that you have been learning in class, so u dot v multiplies the coordinates of u, where are they? The coordinates of u are 2, 3, 5, and the dot times multiplies the coordinates together, and then summing them up gives you the dot product. So dot uv gives you the same thing. Okay, remember the standard basis vectors, remember those. Call those like E or what's it, E1. You can call them whatever you want to. 1, 0, 0, and you can input things in the same line. That's okay. So we should expect that for those two vectors, the dot product of those two vectors is 0 because the standard basis vectors are orthogonal, and the dot product is 0 on orthogonal vectors. So that's sort of again using another way how you could use MATLAB. Here's a question, and my question is give equation of it's the parametric equation. So parametric equation of the line through u parallel to w. So that's my question. I want a parametric equation of the line through u parallel to w. You can call it line. You can create, so you say line equals, or my line, I don't know, my line equals, this is the funny part, you want to put at, parentheses, t, parentheses. That sort of means, that tells MATLAB you're going to create essentially a function of t, and you simply want to write u plus t times w. Done. So then if you write, what is my line, if you want to compute my line at t is equal to 0, you get a number, you get a vector, 2, 3, 4, 2, 3, 5, and is that the vector u? Sure enough. But what you can also do is you can compute my line at 0.1, you can, and so on. You can compute it at pi, you can compute my line for all real numbers. That's pretty cool. We know how to do a dot product, trick equations that we just created, not vector equations, because there's this parameter t. So then if you want to plot the vector 1, 2, you enter it in this way, and it will pop up the point 1, 2. We should see the point 1, 2 somewhere. Right in the middle, I see, yeah, sure. And you can make that point grow a little bit by changing the marker size, and this is only for the experts who want to go here, go there, but that's a way that you can make that bigger. Continuing the introduction of MATLAB, this portion of MATLAB contains names of files that live in the directory that MATLAB can see. So I've got lots of files, and you'll see a lot of them in .m. .m is sort of is a special name for MATLAB, and I'll explain that now. So just as I can do 2 plus 3, and then I can take that, and I can do v is equal to 1, 2, 3, 4, 5, and say if I want to take v and I want to add v is, I forgot to put my tick mark on v. So suppose I wanted to do all 3 of those commands. I wanted to, what did I want to do? I wanted to add 2 plus 3, then I wanted to declare, define v, and then I wanted to add, I guess I needed to define w as well, and then if I wanted to define this linear combination, I could do all of that in this command window. That's what this is called. Or I could type the words edit my code.im. What that's going to do is create for you, this one would do it. Clicking on that one would say, that little new script, that's what we're creating. So if you click on that, that would do the same thing, except it would not give it a name. Okay, so what I wanted to do was create this thing called edit my code, and it's going to bring up a new window that you can change the size of. And it does not affect the other sort of what you know as MATLAB, which is happening here. Now here, you have to imagine what you type here occurring, actually gets, gets inserted into MATLAB. It's a percent sign, so it's a percent sign sort of tells MATLAB, don't try to treat this as MATLAB, treat this as just text. So then I could go over to my history, and I could say, well, I want to do this 2 plus 3. I want to copy all of that, so I can copy all of this that I typed. And I can go here, and I want to paste that in using the paste button. So if you've used Mathematica, if you've used Maple, it's like a Maple worksheet. It's like a Mathematica notebook, the same kind of thing. It's just an external place for you to work so that you don't have to spend all your time in the command window. You can write this once, and then you can save it, clicking the save button, and come back to it. So now you can save that, and it's going to save it in your directory. This directory here should match what's up here. Otherwise, MATLAB won't know what you've done. And then you can come back here, and then you can type the words, my code, simply that, and it will do all of those things. And I probably, one of these doesn't have a tick mark. So save it again, go over and run my code, and voila, that works. So that's what I suggest you doing, is using this edit command. And then if you close that, obviously it's not going to delete it, right? It's just going to sort of remove it from your visible workspace. Oh yeah, so there's a few other commands that I've created for you, something like, and I'll put these up on the web. They're pretty fun, so you can start using them. I have this thing called plot segment, and it's going to allow you to plot the segment between the vectors u and pv. I think I've got this plot segment only working for vectors in R2, so let me define some new vectors in R2. Say like u is equal to 1, 2, and v is equal to, 3, 6, or 3, 5. So if we do plot segment on that will, we tell it to plot in color blue. Let's look at sure enough, this is the endpoint of this is 1, 2, and the other endpoint is 3, 5. You can click on this button here. That will allow you to rotate this and sort of see it in 3D, which will be quite handy and cool. We'll do lots of this. So let's suppose you want to overlay that with another vector. Say, let's suppose you want to plot the segment that starts at u and ends at u plus v. I have no idea what that's going to do. But what you want to do before you do that, you want to type the phrase hold on, and that just means that what you're going to plot next, you want to put back on top of the original one. And let's see if that worked. Sure enough, we've got these two vectors that are both starting at this endpoint that we wanted. So I hope that you will start to play around with this.
You created it?
Yeah, super easy. You can. I will post it on the web. It looks like this. So let's do edit. What was called plot segment, and it's simply this. Now this is some fancy mumbo jumbo, but the guts of it, you absolutely know, which is this formula. The way in which we're plotting that segment is precisely this math that we're learning.